Hi everybody, welcome to another review in trigonometry. As always, there will be a timestamp in the description. You will see the formula on that side as well. Alright. Actually, I started the problem, but I forgot to hit the record button, so I have to start again. So we on the first problem here. So we have triangle ABC and angle A, B, and sine C are given. But if we are given two angles, we can find the third angle easily. So that's not a problem. So if we are given A and B, we can find C. So C is equal to 180 minus A minus B. So C is 103 degrees. So we know C is 103 degrees. Now, in this triangle, now we know the angle C and the sine C. Every time we have an opposite sine and angle, that is the law of sine. So once again, the law of sine is useful when we have a pair of opposite angle and sine. So this is going to be a law of sine. So we write the law of sine. Like that. Of course, the formula is there. And then we put all the information we know. And so that sine of A is 26 degrees, B is 51, and C is 103 degrees. And then A and B we know, or we don't know, the sine C is 22, so we're going to do that. We use the calculator a lot, so let me put the calculator there. And also very important that the calculation have to be in degree mode, so I leave in degree mode. Right. So first, since we know the opposite, a pair of opposite sine angles, so we're going to use this ratio. Then we can use this ratio to find B. So cross multiply, then we have 22 sine of 51 degrees equal to B times sine of 103, and so for B we have that. Okay, calculator in degree mode, which is good. Right. By the way, and also the calculation. Let's see what happens if we have in the radian mode. That's what we have actually. So don't need that. So 22 sine of 51 divided by 102 sine of 103. That is 23.67 or so. The reason that, of course, by that vacuum it's just a number, we cannot tell if it's right or wrong. But what we can tell is that in this triangle, opposite to the biggest angle have to be the longest side. So whatever we have for B have to be less than 22, and that's not supposed to be. So we know there's something wrong when we have anything bigger than 22 is going to be wrong. So one of the usual problem is the calculator must be in the degree mode when we do that. Right. Now let's just go there, copy and paste. So that's 17.5. We round to the nearest 10. So side B is 17.5. Right, so we use those ratio to find B, and then we can use this ratio. Actually, just oops. Yeah. So the first and the last here. Again, cross multiply. A sine of 103 degrees equal to 22 sine of 26 degrees. So for A we have 22 sine of 26 degrees over sine of 103. Right. So 22 sine of 26 divided by sine of 103. is 9.9. Right, and then we can put it back into the prompt. If so, we have A is 9.9, I mean meter, and B is 17.5. So 9.9 and 17.5. So biggest angle, longest sine, smallest angle, the shortest sine, and that. So that works. So that is the first prompt. Right. Then we'll go to the second prompt. This one we are not given the triangle, so we have to draw it. It doesn't matter, just anything generic will do. So just draw the triangle. Right. So in this triangle we are given angle A 70 degrees, angle B because we just draw that so to have something to refer to. We don't know C. For sine, opposite to angle A is sine A 5 meter. Right. So regardless, in this triangle we are given two angles. So let's find the third one. But first let's summarize the data as we have before. So we have A 70 degrees, B 20 degrees, and then C we don't know. Opposite to that angle, sine A is 5 meter, B we don't know, and C we don't know. Right. So as always, if we know two angles, just find the third one immediately. That is the easy. By the way, if that is 70 and 20, so that will be 90 degrees. So this is not really an oblique triangle, but that's fine. You can always do that. A plus B plus C is 180 degrees. So now we can solve for angle angle C, 180 minus A minus B. So 180 minus A is 70, B is 20, so C is 90 degrees, and that is C. Right. Even though it is the right triangle now, but we just still using the law of sine or the law of cosine. Right. So in this problem we are given a pair of opposite sine angle. Every time we know that is the law of sine. So when we see this, so that is the law of sine. Right. So law of sine. Again, I'll write the formula. Sine A over little a, sine B over little b, sine C over little c, and put on everything we know. Sine of 70 degrees over A 5 meter, sine of B 20 degree over B, we don't know B, and sine of 90 degrees for C, we do not know the sine C either. Right. We just pick a pair ratio and then solve for the missing one. We always use the sine 70 over 5. Cross multiply B sine of 70 degrees equal to 5 times sine 20 degrees. Cross multiply b equal to 5 sine of 20 over sine of 70 degrees. Right? 5 times sine of 20 degrees divided by sine of 70 degrees is 1.8 meter. So if it is 1.8, look reasonable because 20 degrees less than 70 degrees. This have to be less than 5, so that's okay. Look reasonable. So that is sine B. Right, now pick another pair of ratios to solve for C. So we're going to use this because this is a known ratio. So we use that ratio. Cross multiply C sine of 70 degrees equal to 5 sine of 90 degrees, and then we will solve for C. 5 sine of 90 degrees, which is 1 by the way, over sine of 70 degrees. So 5, pretty much just 5 divided by sine of 70 degrees, because sine of 90 degrees is 1. So it's 5.3 something. Let's keep 5.3 meter, and that is the sine C. Let's put so sine C, little c, 5.3, would make sense because this is the biggest angle will face the longest side, and little b is 1.8. The shortest side face the smallest angle, so that works there. Right, times 10. Right. So this we will have a bunch of other triangle to solve for. Right, let's just draw it. So A, B, and C. Right, angle A is 30 degrees. Sine A is 21. Angle B is 42 degrees. Actually, that is the sine B is 42. Right. Oh, one thing I forgot. On the last one, this one is the angle, and sine. Case. With that. Alright, so this one, what do we have? We have an angle, and then sine, and sine. Pretty much two sine, but not the angle in between. So in this case, we call sine, and angle. I don't want to spell backward. Right. So we don't have the angle here is unknown, angle here is unknown. So we're not going to use A plus B plus C equal to 180 because we only know one angle, and we don't know sine C. So let's write out what we have. A 30 degree, opposite to that little a 21. Angle B, we don't know that. Angle C, don't know that either. We do know that the sine B is 42, and we do not know sine little c. Once again, in this scenario, we have a pair of opposite sine angle. So every time we see this, that is the law of sine. So write out the formula: sine A over A, sine of B over little b, and sine of C over little c. Put everything we know in that equation. Sine of A 30 degrees over little a 21. Sine of B, don't know that, over little b 42. Sine of C, we don't know. Sine C, we don't know either. So this is useless. We're not going to be able to use C in this scenario. We're going to use this ratio for sure. So if we consider first two ratio, cross multiply, and we can solve for sine of B. Right? So cross multiply 42 sine of 30 degree equal to 21 sine of B divided by 22. We have sine of B equal to 42 sine 30 degree over 21. So that's 2 times sine of 30 degrees. Right. 42 times sine of 30 degrees. So that's 21 divided by 21. So that is 1. Again, this is should not be the case, because again we should have the oblique triangle. Anyway, so if it is 1, to get an angle, we have sine inverse of that ratio give us 90 degrees. But remember, when we solve for the equation of sine, we can also have the supplementary. So we're going to have 180 minus sine inverse of 1, which is also 180 minus 90. So it's 90 degrees as well. So it just happened to be the same. So in this case, we only have one solution. It's not supposed to be like this easy, but we could have more complicated scenarios. So anyway, it's 90 degrees of angle B. Right. Now we will go to the angle C. A plus B plus C is 180 degrees. So we always have that. Once we know 2, we can find the last one immediately. So C so C 180 minus A minus B minus 30 minus 90 is 60 degrees. So that immediately C is going to be 60 degrees. And then we can put CC here. That's 60 degrees. Right. Now we just need to find the sine little c. Let's use this ratio. The first and the last ratio. So I'm going to write here cross multiply c times sine of 30 degrees equal to 21 sine of 60 degrees. And we solve for C, so C equal to 21 sine of 60 divided by sine of 30. So we do that. 21 sine of 60 degree divided by sine of 30 degrees. So 36.37. I say 36.4. And we have 36.4. So it makes sense now because the biggest angle long is sine, smallest angle short is sine. So that makes sense. In this case, we have only one solution because those happen to be the same. Right. So times 10. Right. So that is sine angle. This scenario could be complicated because we might have no solution, one solution, or two solutions. Right, so this one we have angle B 39 degrees. Sine B is 4 and sine A is 22. Right, we don't know A or little a or little c or angle C. Let's write out again. A 30 degree. Sorry, don't know that. So just box there. B 39. C don't know. Little a don't know. B actually A is 22. Sorry. Little b is 4 and we don't know C. Usually we should have given 3 and we find the other 3 that are missing. Right. So once again, a pair of opposite sine angle. So this is the law of sine. So I just keep the formula. Sine of A, we don't know A, over little a 22. Sine of B over B 4. Sine of C, we don't know angle C, and we don't know sine little c. Right, let's put everything we know, everything we know in the formula. So the only thing we can do here is find over sine of A. So cross multiply 4 sine of A is equal to 22 times sine of 39 degrees. Let's cross multiply and then we divide. So sine of A equal 22 sine of 39 degrees over 4. 4 times sine of 39 degrees divided by 4. So about that. So A will be inverse of that. Let's just write 0.629. Right. So sine inverse of that. So second answer. I should put sorry about that. It should be 22. Okay, again 22 sine of 39 degrees divided by 4. Sorry, I put 4 and 4. Right. So I have that 3.46. Sorry, I put the wrong number. So sine inverse of 3.46, and obviously if you do that in the calculator, it's going to be undefined because sine is supposed to be between only 1 and -1, and they give us an error. We see. So in this case, because this have no solution, so this one has no solution. So this is another case of sine angle, and earlier we see the same sine angle with one solution, and this one has no solution. Potentially we may have two solutions, so that could be the case. Let me write the timestamp. So next one, again a kind of generic triangle A, B, C. We are given B 17 degrees and side B 13.8, A 15.73, and we don't know C, don't know sine C, and we don't know angle A. So let's summarize. A, we don't know A. Sine A we do know 15.73. B 17 degrees, little b 13.8. C, we don't know C, or little sine C, so we don't know either one of them. Right. So again, we have a pair of opposite sine angle. So this one, once again, is a law of sine. So put all the information we have. Sine of A we don't know, over A we do know. Sine of 17 over 13.8 equal to sine of we don't know C over little c. Right, so we cannot use that, but we can use the first two. Cross multiply 13.8 sine A equal 15.73 sine of 17. So that cross multiply. Now we solve for sine A. So pretty much this divided by 13.8. Just hit enter to quick. 15.73 divided by 13.8. Sorry, 15.73 times sine of 17 divided by 13.8. And we have 0.333. 3. Right. So we can get A equals sine inverse of that. So I just say sine inverse of that number. So just hit enter, copy and paste, or we just hit second answer to pull up the last number. But anyway, we have 19.46 let's say 19.5. Or just 19 degrees. They do 1 to the nearest degree, so that's 19 degrees. That's right, just 19.5. Right. So if A is 19.5, it looks reasonable now because 19.5 is bigger than 17 and the sine is bigger than 13.8, so that makes sense. But remember, every time we solve for the equation that have sine A, we always have the supplement to it. So the supplement 180 or pi minus this 180 minus that, so 160.5. Remember, this is also bigger than B and the sine A bigger than B, so both of these should work. At the end we put everything in and then we determine if it works or not, but for now look like there are two scenarios. The first one we have, of course, all this information, but the first one we have A is equal to, let's use 19.5, and B is always that 17, and B is always 13.58, A is 15.73, C still don't know, little c still don't know. Now we have two angles, we can find the third one easily. So again, A plus B plus C equal 180 degrees. So 180 minus 19.5 minus 17 is 143.5. 143.5, and finally we can use the law of sine to find C. So let's just do that again. Now we just since we know this ratio, so we're not going to use A, we use this two ratio, sine of 17 degrees 13.8 or sine of 143.5 over we don't know C. Cross multiply C of sine 17 equal to sine of 143.5. So for C, I didn't even multiply 13.8 times sine. Anyway, cross multiply. So 13.8 times sine of 143.5 divided by sine of 17 degrees. And we have 28. Right. Point 1, if you will. So that looks like one answer. Right, let's check. Biggest angle, longest sine, smallest angle, shortest sine. So that works. So that is one of the solutions. We might have two. The other scenarios is where we have this 160.5 degrees. So let's write that out. A 160.5 degrees. B 17 degree, little b 13.8, little a 15.7, 3, c don't know, and little c we don't know that either. Right. So a plus b plus c, so subtract from 180. Now this will be easy. Now 180 minus 160.5 minus 17, 2.5 degrees. In that case, C will be the smallest one. Again, the ratio, pretty much this, same ratio, sine of 17 degrees over 13.8 equals sine of 2.5 over little c. So little c is 13.8 sine of 2.5 degrees over sine of 17 degrees. 13.8 sine of 2.5 divided by sine of 17. This is 2.05, so it's equal to 2.1. Right. 13.8 sine of 2.5 divided sine of 17. So it's a little off, but that's fine. Right. So yeah. So in this case we have two solutions. Again, biggest angle long is sine, smallest angle short is sine. So again, this case we have another sine angle situation, and here we have three examples. It could have one solution, two solution, or no solution, and we have one of each. Next, we have this case. Once again, let's just write down what we have. Angle A, 45 degrees. We don't know little a. Angle B, we don't know. By the way, this is opposite to angle C, so that is C. And this is opposite to angle B, so this is B. A, of course, we don't know. But little b, 5. C, we don't know angle C, but we know little sine C is 4. Right. So what we have here, sine, angle, sine. Sine, angle, sine, we have a unique solution. Right. Now we don't have a pair of opposite sine angle. So this we have to use the law of cosine. So law of cosine over there, let me highlight it. So this we law of cosine, and of course we're going to use the first one here because we are given angle A, so we have to use the one that have A in it. So the first one, A squared equal to b squared plus c squared minus 2bc cosine of a. So we start with a, end up with a. Everything else, the other two letters. Right, so put everything we know. B squared, 5 squared, plus 4 squared, minus 2 times 5 times 4, cosine of 45 degrees. 5 squared, plus 4 squared, minus that 20, and times 2 to that 40, cosine of 45 degrees. At 12.7, whatever that is. 12.72. Alright, we'll check the whole number. Remember, this is a square, not a. So to get a, we take the square root. So we take the square root of that number. Copy and paste. 3.56. Round the answer to the nearest 10. So 3.6. Right, now we have a pair of opposite sine angle, so we can use the law of sine again. Just going to write the law of sine. Sine of 45 degrees over little a. Sine of b we don't know, over little b we know is 5. Sine of, we don't know big C, we know the size C is 4. Right, cross multiply, and that's easy. So we know this ratio, we should use this. So let's group this one. Right, let's use green here. So 5 sine of 45 degrees equal to 3.6 sine of b. So sine of b equal 5 of sine of 45 over 3.6. 5 sine of 45 divided by 3.6. So 0.98 something. Right, take the inverse of that. We have b is equal to sine inverse. Alright, so sine inverse. Again, we can always go up there, hit enter. But if your calculator cannot go up, we can hit second answer, and that will do the same. 79.14. Right. If you wonder why the answer is a little off compared to the answer on the back of the test, because here we round up to 3.6. If we don't round it up, let's see. So instead of 3.6, we use this number, and we're going to take the sine inverse of that. Of course, it's going to be different. It's 82.5 degrees. So even though we round up 3.6, but we should actually keep the original number, 3.56 something. So this will be 0.9914. Yeah, this number round off. have 82.5 degrees. By the way, I'm not worried about that. On the test, if you round up and you have a number, so whatever number works, if the math is correct, it will be correct. So 82.5, remember, it could be also the supplement to it. That is a drawback when we use the law of sine to find angle. So 180 minus that, 180 minus that, we have 97.48. Right, my question is which one which? 5 for B, right? So B is, sine B is bigger than A, so we know the answer is going to be bigger than 45 degrees. And we do have both of them bigger than 45 degrees. So we just have to use both of them. Right. But we know that this scenario only have one solution, so only one of them will work. Right. So let's look at the bigger one, 97.48. Okay. We assume that B is equal to 97.48. If that is the case, C, we can subtract from that 180 minus 45 and minus 97.48 degree. So 180 minus 45 minus 97.48, 37.52. Now, if we're going to put C here, that would be the smallest angle, but this is not the shortest side, so this one doesn't work, because once again we have the angle C is less than angle B, but little c is bigger than, it should be A, sorry. But little c is bigger than A, so this one doesn't work. Again, opposite to biggest angle is the longest side. So 97.48 doesn't work because the sine angle doesn't match. So it has to be only 82.5. So in that case, B have to be 82.5. So that one we're sure of, 82.5. So we're going to put here permanently 82.5 and subtract from 180. That will be easy. So angle C is 180 minus 45 minus 82.5. 180 minus 45 minus, just copy and paste. I show about that, 52.5. Right, so biggest angle, longest side, smallest angle, shortest side, so that makes sense, and how that works. To the next example, to the next problem. Triangle. So we are given sine A is 22, sine B is 33, Then C is 42. So we're given all the sides. So this one is the sine, and sine scenario. Let's try now what we have. Don't know A, but sine A we know. Don't know B, but we do know sine B. Don't know C either, but we do know little c 42. Right? So obviously we don't have a pair of opposite sine angle. So law of sine is not an option here. We cannot use law of sine. So we have to use law of cosine. The question is which one we do here. Usually the law of cosine, and we're going to keep the one with the biggest angle, which is going to be C. So we're going to use C. Because of that, later on, if we have to use the law of sine to find an angle, we don't have to worry about the supplement or not, because again, C have to be, it's going to be the biggest angle. So if we use the law of cosine to find an angle, let's go with the bigger one, the biggest one. So it will be C squared equal to A squared plus B squared minus 2AB cosine of C. C squared 42 squared equal to A squared 22 squared actually it would be better if we just solve for cosine of C. So minus A squared minus B squared, so we write negative 2AB cosine of C equal to C squared minus A squared minus B squared. So cosine of C equal to C squared minus A squared minus B squared over negative 2AB. Right. C squared 42 squared minus A 22 squared minus B squared 33 squared minus 2 times A 22 times B 33. Right. I just put the parentheses here. 42 squared minus 22 squared minus 33 squared divided by negative 2 times 22 times 33, and we'll have negative 1.13, and then we will take the inverse of cosine, and look like we have that. The good thing about the law of cosine is, let me just write it out first. So cosine of C is equal to negative 0.13154 something. So C equal to cosine inverse and we have 97.6 degrees. Right. The good thing when we use the law of cosine to find the angle is, remember when we solve the equation, trigonometry equation involving cosine, not only we have this, we have to have the opposite as well. But if it's opposite, it's going to be negative, and we cannot have negative angles in a triangle. So we have only one solution here. So pretty much that's that. Now we know for sure C is 97.6 degrees. Right. And we can use the law of sine to find the angle. But since we use this to find the angle already, now let's switch it up, find the next biggest angle, B. So we have another law of cosine, but we start with B, and we're going to end up with B. the middle will be different letters. So let's solve for cosine of b. To AC. So for that term, so b square minus a square minus c square. So cosine of b square minus a square minus c square, or negative 2ac. B square 33 square, a square 22 square, c square 42 square, over 2, negative 2 times a 22, c 42. 33 square minus 22 square minus 42 square divided by negative 2 times 22 times 42, 0.627. We're going to take inverse of that. Cosine inverse of that is 51.2. Again, when we use the law of cosine to find angle, what we have is just that. So we will not have any other case because we cannot have the negative or the opposite of that angle. Right, and then subtract from 180, we have angle A. That should be easy. 180, A equal to 180 minus 51.2 minus 97.6, and we'll have it 180 minus this angle minus that angle, 31.3. One thing that should be degrees, so that's good. Yeah, the angles, so you have the degrees. Right, smallest angle, sorry, sine, that works there. Biggest angle, longest sine, so that's what we have. Right, that's shown in the triangle. Now we switch gear to another one. This one, we put the calculator away because we're not using calculator much here. So what next is the polar coordinate. The polar coordinate is, instead of x and y, we use r and theta. And there's pretty much nothing new here. We have this set of formulas. X equal to r cosine and y equal to r sine. Even not before that, let's just do something very simple. The first one, plot the point having a given polar coordinate. And we'll just see how it goes. So the radius is equal to 4, and the angle is theta is 225 degrees. So radius is 4, so that will be in the circle radius of 4. 225 is in the fourth quadrant, so it's going to be this point. So the radius is equal to 4, and the angle is 225, which is this angle, 225. So that's just that. Right. Next one, given the point in polar coordinate. So this in polar, meaning that r is -1 and theta pi over 2. So this one in polar. We're going to convert this into rectangular, meaning we're going to have x and y. It's very simple. The formula is straightforward. X equal to r cosine theta and y equal to r sine theta. This is because we have cosine is x over r, so cross multiply x equal to r cosine, and same thing for sine. Sine is y over r, so multiply r over y equal to r sine theta. So just have that. So -1 cosine of pi over 2 is 0. So it's just 0. And then -1 times sine of pi over 2, which is 1. So that's just -1. So the point here is x equal to 0 and y equal to -1. And that's what we have. Right, next one. Convert the rectangular coordinate point to the polar coordinates. Right, so this is in rectangular, meaning that on this one x is 6 and y is -6 square root of 3. Right, we need to find r and theta. So it's easy. Have x squared plus y squared equal to r squared. So we have r equal to square root of x squared plus y squared. This we assume because r is positive. R could be negative as well. In that case, this might change. This will change. Right. Actually, I'll just do it by hand. 6 square plus -6 square 3 square. So 6 square 36. 6 square 36 again times 3. So that 36 times 4 and 144. So this is going to be 12. Square root of 144 is 12. So r is 12. Just don't know the angle yet. So to determine the angle, we have tangent of theta is equal to y over x. Y -6 square root of 3 over x 6. So tangent of theta is equal to negative square root of 3. Just have to bring the calculator up again. Tangent inverse. Tangent inverse. Negative square root of 3. Right. Negative 60 degrees. Let's use pi. So negative pi over 3. Right. Is that the right answer though? Let's check. Negative pi over 3 look like 4th quadrant. So do we have 4th quadrant? Because x is positive and y is negative. Yes. So this point is in the quadrant 4. And we have the answer in the quadrant 4. So that this answer is good. We can even write like that. Except they want the angle between 0 and 2 pi. So let's convert that. We're going to add 2 pi to it to get a coterminal angle. And that gives us 5 pi over 3. Yeah, they just want the answer between 0 and 2 pi. So that's what we have. Right. Next we have this. Convert the rectangular equation to polar form, and then next we do the reverse. So the first one's too easy. Let you do that. 2 to 1, 11. So x squared plus y squared. Remember, we still have the set of formulas. Put calculator. Still the same set of these formulas here. So we see x squared plus y squared, right? So that is always r squared. And x, so we use x squared plus y squared equal to r squared. And then x is r cosine theta equal to 0. Move that over. And we can divide by r on both sides. Assume r is not equal to 0. So we have r equal to 4 cosine theta. Next one also simple. Y is equal to r sine theta. So for r, so we divide by sine of theta on both sides. Reciprocal of sine is cosecant. So that's all we have. So we can even if the answer this form. Right. Next we do this in reverse. We have the polar, now we convert to rectangular form. Right. So theta is equal to 5 pi over 6. So what we can do here, in that formula, we only have tangent of theta, so we should use tangent. So I'm going to take tangent on both sides. So tangent of 5 pi over 6. Tangent, I just use a calculator. 5 pi over 6. So that's like 150 degrees. And we have, yes, negative 1 over square root of 3. I shouldn't write that. Should be tangent of theta equal negative 1 square root of 3. Right. And finally, tangent is equal to tangent of theta is equal to y over x. So this is y over x equal to negative 1 over square root of 3. Let's cross multiply negative square root of 3y equal to x. And that is the equation. Right. Next one is a little less obvious. R equal to 10 sine of theta. Right. Remember, we don't have sine by itself, we have tangent. If it's tangent, we use y over x. This is not. So what we can do is, if we multiply r on both sides, put the r there because r sine theta is going to be y. So we have r squared equal to 10y, and r squared is x squared plus y squared. So we have x squared plus y squared equal to 10y. So this is the equation in rectangular coordinate in x and y. Right. Now we're on to the last part of the review, complex numbers. Right. So adding this is very simple, just combine like terms. So we're going to have 12 plus 7i minus 3 plus 2i. So 12 minus 3 is 9, and so that's 9 plus 9i. Except I do it wrong. The minus here should distribute inside, so that should be minus. And 7 minus 2 is 5i. Right, so that's straightforward. If we use the calculator, we're going to hit mode and turn to the complex mode with a plus bi, and then we can just say 12 plus 7 second decimal, that's 7i minus 3 plus 2i. Yeah, so that's straightforward. But keep in mind that if we're not using the complex, I highly recommend we switch back to the real mode. Otherwise, there's something strange, or it gives you errors, so here and there. Right. Right. Of course, you can check using the calculator, but I'm just going to do by hand for all of this. So this multiply, we just multiply naturally. 6 times 5, 30. 6 times negative 9, negative 54i, negative 10i, and plus 18i squared. Right. Combine like terms. 30 minus 54 minus 10 minus 64i, plus we have I squared. I is imaginary. I squared will be negative 1. So we're going to substitute in. So 30 minus 18, 12 minus 64i. It's straightforward. Except the divide is a little bit less obvious. Of course, we cannot divide quite like that. What we can do, just like when we have the square root at the denominator, what we should do is we multiply by the conjugate. In this case, the complex conjugate. So this is a plus, so we multiply by that top and bottom. Multiply by the conjugate, we eliminate the middle terms. So 5i on the top, we multiply that later. Now let's multiply 3 times 3 is 9. 3 times that negative 21i plus 21i minus 49i squared. The top will be 15i minus 35i squared. middle terms cancel out because that is the conjugate multiplied by conjugate. I square is always -1. So at the bottom we have 9 minus 49 times -1. I square is -1. 49 plus 9 is 58. And we have 15i. Again, I square is -1. So rewrite this, we should have 35 plus 15i over 58. The standard form is a plus bi. So we're going to write 35 over 58 plus 15 over 58i. That's what we have. Right. So write the complex conjugate and then multiply. The complex conjugate is just the same thing, except instead of plus I, there will be minus. The opposite of that. That's the conjugate. Let's put the calculator away. Right, now multiply z and z complex conjugate. Z a plus 3i, a minus 3i. That will be 64 minus 24i plus 24i minus 9i squared. I square is -1. So we have 64 minus 48i minus 9 times -1. So 64 minus, sorry, the middle term cancel out. That's why we every time we multiply by the conjugate, the middle term always cancel. So 64 plus 9, that is 73. Next, find the absolute values of a complex number. We can do this two ways. Let me write the question. Timestamp. Right. So the absolute values of the complex or the modulo can be defined as the product, square root of a number and its conjugate. So we can do that. Or if we write this in the form 3 plus 10i, this is going to be x, and that's going to be y, and z, absolute values or the modulo of z is equal to just x squared plus y squared, we have square root of that. So 3 squared plus 10 squared, square root of 109. That's what we have. So complex number, the real part is x or r cosine theta, and the imaginary part is y or r sine theta, if we're going to use that later. Right, timestamp. Right, 120, 3 plus I. So 3 is going to be x and I times 1. So y is equal to 1. So 3 on the x, 1 on the y, and this is the Poon. Pretty much 3 and 1. Right. Next, Write the complex number in polar form and express the answer in degrees. Oh, so that's very simple. Again, the real part is x, imaginary part is y. So if x equal to 4 square root of 3, y equal to negative 4, and into polar form, so we're going to convert this into r and theta. Right, so first r is equal to square root of x squared plus y squared. 4 square root of 3 squared plus negative 4 squared. 4 square root of 3, that 16 times 3, 48, plus 16 square of 64, which is 8. And then we determine theta. Tangent of theta is y over x. Y over x. So that is negative 1 over square root of 3 taken inverse. Of that, we should have negative pi over 6. Right. Let's see. Calculator. Tangent inverse of negative 1 over square root of 3. Oops. Square root of 3. There. Right. It's good in degree mode, so it's okay there. Negative 30 degrees. We always check to make sure that it's in the right quadrant. 30 degree, negative 30 degree is in quadrant 4, and the original point x positive, y negative. So yes, the quadrant 4 is correct. So negative 30 degree is good. However, they want between the 0 and 360. So let's just add 360 or 2 pi to it. And so we have 330 degrees. Right. So x, y equal to I, we can rewrite this as in general, it's going to be r cosine theta plus I sine theta. But we can factor out the r, so I have cosine plus I sine theta. Of course, I put the calculator on the way, but you can see we can write z as this, cosine and then I sine theta. So r is 8 cosine of 330 degrees, I sine of 330 degrees. The next one's too easy, just multiply it out. 6 cosine of 330 degree plus I times 6 sine of 330 degrees. Do the math here and get the numbers. So we're not going to skip that question. That's too easy. Right. Next we will do either multiplying, divide, or powers, or root. So the remaining part of the complex number. So first we're going to write this in polar form, and then do the multiplying, divide, or powers, or root. Right. So first write this in polar form. 2 and 2i. We can even draw that easily. 2 on the real or the x-axis, 2 on the imaginary on the y-axis. So the point is there. We can also say 45 degrees and 2 and 2, so that's square root of 2 square root of 2. We can almost do that by just round in it, but just do that. So z1 is equal to 2 plus 2i. Now we convert this to polar. So x is 2, y is 2. And r is square root of x squared plus y squared. Which is square root of 8. Or 2 square root of 2. Or square root of 4 times square root of 2. Or 2 square root of 2. Right. So that's r. Theta. Tangent of theta is y over x. Y over x, which is 1. So theta is tangent inverse of 1, which is good. 45 degrees. Or could be something else, but 45 degrees in the first quadrant, so that's good. We're not going to mess with that. So we can have, that is z1. We're going to write in the form of, in the polar form, r cosine theta plus I sine of theta, or 2 square root of 2 cosine of 45 degrees plus I sine of 45 degrees. Right, so that is z1. We do the same thing to find z2. When we have this, the multiply will be very easy. Z2 square root of 3 minus I. Again, this is x is square root of 3 and y is negative 1. Remember, that is only the imaginary parts, so there's no I in it. Right. So once again, r is square root of x squared plus y squared. We have 3 squared plus negative 1 squared. So that is 4. Square 4 is 1. 2, sorry. So as 2. Tangent of theta, y over x, negative 1 over square root of 3, tangent of theta, is that. So theta is tangent inverse. So that should be 330 degrees. I think we did plenty of that. Yeah, we did this earlier. So 330 degrees. And this is in the quadrant 4. And we have x positive, y negative. So yes, it is in quadrant 4. So 330 degrees. So z2 is equal to r cosine of 330 plus I sine of 330. Right, now the product of those two will be very easy to do. So z1 times z2, 2 square root of 2 cosine of 45 degrees plus I sine of 45 degrees times I'll run out of space, so I have to write that below here. Cosine of 330 degrees, I sine of 330 degrees. Right. So when we multiply two complex number in the polar form, we just multiply the absolute values or the radius or the modulo. There's a bunch of different names for it. That's 4 square root of 2. So multiply this, and then we add the angles. 330 plus 45. That 375. That is correct, but the answer between 0 and 360, so let's subtract 360 from this, and we have 4 square root of 2 cosine of 15 degrees plus I sine of 15 degrees. The next one is easy. It is already in the polar form. So when we divide, the formula for the division is this. We divide the modulo, and then we subtract the angle. So that one rather obvious. We just have that. Again, I'm going to skip 114, 124. That's too easy. Formula just right there. Divide the radius on the modulo, subtract the angles. The last part is the De Morgan theorem. So if it is in this form already, this is very easy. So the De Morgan theorem is this. So pretty much we're going to raise the power and going to multiply the angle by that number. So this will be 3 to the 4th power cosine of 4 times 15 degrees I sine of 4 times 15 degrees. So 81 cosine of 60 degrees plus I sine of 60 degrees. So that's good and all, except for this one, they want that in a rectangular form. So let's convert this easily. Cosine of 60 degrees, square root of 3 over 2. Sorry, I've got them backward. Cosine of 60 degrees, 1/2, plus sine of 60 degrees, square root of 3 over 2. Now multiply it out, 81 over 2, plus 81 square root of 3 over 2i. So that's all we do, pretty much. So the Morgan theorem for powers, raise the power to that exponent and multiply the angle by that exponent. So that's pretty much it. This is actually also part of the De Morgan theorem as well, but this is the complex root. So there will be a bunch of complex root, depends on what is the root. So we have the square root of 1 minus I, right? So we write the answer in polar form. So first we will write this in the polar form, 1 minus I. So let's write Z, or in this case the formula we have is W, so let's use W is 1 minus I. If we write the corresponding rectangular form, will be x equal to 1, y is negative 1. From here we can find r and theta easily. R square of x squared plus y squared so that's square root of 2, and then theta, tangent theta is y over x So tangent of negative 1 negative 1 I meant the inverse. Alright, negative 45 degrees. Right, we always have to check though. 1 and negative 1, so that in the fourth quadrant, so this in fourth quadrant, so it is good. If it is in the second quadrant, we have to add 180 or pi into it, but we don't. It's in the correct quadrant. The answer is still between 0 and 360, so why don't we add 360 to it to have 315 degrees coterminal angles. So our theta is equal to 315 degrees. So we write the complex number z equal to r cosine theta plus r sine of theta, r square root of 2 cosine of 315. This is supposed to be w. Sorry. What we do next is, of course, square root on both sides, or 1/2 power. That's kind of like the Moore theorem. So we're going to multiply this and divide the angle. Except the only thing different here is we have to add the multiple of, put the calculator on the way again. We're going to have to add the 2k or 360 degree of pi divided by n. Right. So in this case, I will write this as, first, the square root of 2 will raise to that power. So square root of 2 just gonna put it like that, right? And then cosine, remember the power or the exponent multiplied the exponent, that will be the power of the modulo or the radius, and then here we just divide that by multiply 1/2 or divide by 2. Don't forget we have to add the multiple of 360. Yeah, kind of like that. Sine of 315 plus multiple of 360k, divide by 2. Sorry, a bit messy there, but let's write again. So the root of w is square of 2 to the 1/2 cosine of 315 over 2. 360 divided by 2 is 180 pi, so plus 180 degrees times k plus I sine of 315 degrees divided by 2, again plus 180 degrees times k and that k will be equal to 0 or 1. Remember the k will have to be less than n, an integer less than n. N is 2, so it can be less than 2, so either 0 or 1. So when we have when k equal to 0, we have one of the root is equal to just cosine of 315 divided by 2. I just write 315 divided by 2 plus I sine of 315 divided by 2. And then when k equal to 1, I'll put 1 in it. W 1/2 equal to square of 2 to the 1/2 cosine of 315 divided by 2 plus 180. Let's just get the decimal from there. 315 divided by 2 plus 180. 337.5. I sine of 337.5. Alright, so square root, so there will be 2 square root. We'll just do that. So when it is in the polar form, we take the root of complex number fairly easily. So take the root of the modulo and then divide the angle by that number. But don't forget we have to have the 360k to it. Divide by n. Right. Next one we have cube root of negative 8. So if we're going to write negative 8 is here, so look like the distance to the origin is 8, so that is R, and the angle is 180. So negative 8 equal to, we write in the complex form, I mean the polar form. Forgot to write the timestamp, so that's at 142.30. Right. So negative 8 is equal to the modulo 8. The angle is 180 degrees. So we can write like this. And then both sides will raise to the 1/3 power. Going to that theorem, we're going to have equal to a to the 1/3 or the cube root of 8, which is 2. And then we have cosine of 180 degrees divided by 3. And then don't forget in that theorem we have to plus multiple of 360 divided by the same number. Plus I sine of 180 divided by 3 plus multiple of 360 divided by the same number, 3. So a to the 1/3 or cube root of a is 2. Cosine of 60 degree, 360 divided by 3, so that is 120 degrees. (60 plus k times 120 degrees). Right. Then we'll just say different scenario when k have to be less than n. N in this case is cube root, so k is n is 3, and n have to be less than that, so be 2, 1, or 0. Right. K equal to 0. We have the first cube root is 2 cosine of 60 degree plus I sine of 60 degree. K equal to 1, Z 2, 60, K is 1, so that 60 plus 120, so cosine of 180, I sine of 180 degrees. K equal to 2, the third solution. 2 times 120 is 240 plus 60, so that's 300 degrees. I sine of 300 degree. Right, so that's all the cube root of -8. Right. One thing to note, if we're going to plot these 3 points, all of them have the radius of 2, but it is 60 degree, 180 degrees, and then 300 degree. So those solutions always divide a unit circle evenly, so in 3 portions. So anyway, so that's that. With that, we finished this review. I hope you find this helpful. Thank you for watching.